Okay, now that we know how to solve for the y-intercept, the x-intercept, the axis of symmetry, and the optimum value, we are going to figure out how to apply that to real-world questions, which we call word problems in math. So let's quickly review how to solve for each of these three things. So the y-intercept, we sub x equals 0 into the equation and solve for y. For our zeros or x-intercepts, we need to factor it, and once we factor it, we take each factor and set the brackets to 0. And then solve for x. You should have two answers, sometimes one, or sometimes they're both the same. When we are looking for the axis of symmetry, remember that's xv, we average the zeros, so that's the first plus the second divided by 2. I'm also just going to write average our zeros. And then if we want to find the optimum value, which is the highest or the lowest value that y can be, so our y value of our vertex, we take our axis of symmetry and we sub our axis of symmetry. I write xv, but we can write axis of symmetry into the equation. So now that we've reviewed how to solve all of these, let's connect them to real life word problems. So the y-intercept, what does that look like? Well, that's in a real world problem, that's your initial value on whatever's happening on the y-axis. So sometimes we do height, sometimes we do profit or income. And so profit is how much money you make after deductions, and revenue is just how much money you make without any cost deductions, etc. Our zeros or x-intercepts is where whatever our x value is 0. So when the height or profit or revenue is 0. So like an example of the height is like, when does the ball hit the ground? When, or where, when, at what cost is it to break even? Sometimes we call that a break even point in terms of money. Those are some examples. Let me just put e.g. Our axis of symmetry is the value of x that produces the maximum. So it's like, when is the ball the highest, or something like that. So it's usually like when something is the highest or lowest, which is that's your x value, right? Where your optimum value is the y value of the vertex. So it's just like maximum or minimum of the y variable. So it's like, it's usually what is the max min value.